Hello dear students of plus one medical, non-medical and respected teachers. Today I am going to discuss a very important topic, potential energy stored in a stretched spring. So suppose we have a spring of spring constant K having some length L whose one end A is fixed to the rigid support, to the other end B a mass M is attached so that the spring is kept horizontal and this mass M is able to slide on a frictionless surface freely. And suppose x is equal to 0 be the equilibrium position of the mass and spring when there is no stretching or there is no compression. Now suppose this mass M is pulled towards right through a certain displacement x. Then due to elasticity of the spring, a restoring force comes into play in accordance with Hooke's law, which states that restoring force is directly proportional to extension produced and it always opposes the motion. So F is directly proportional to minus x by Hooke's law, or F is equal to minus kx, where k is known as spring constant or force constant, and the spring constant and force constant is defined as restoring force per unit extension produced in the spring. So by Hooke's law, when this mass M is pulled towards right, a restoring force comes into play due to elasticity of the spring. When this mass M is released from this extreme position, it turns back to the mean position. And while doing so, it attains speed, it attains kinetic energy, and it overshoots the mean position towards left. Now, as soon as it overshoots the mean position, spring gets compressed. Again, restoring force comes into play due to elasticity of the spring, which opposes the motion of the mass, and it stops at left extreme position for a moment. Then returns back to the mean position. Again, gains kinetic energy, overshoot the mean position, and this process continues. If the surface is frictionless, this mass M after releasing starts oscillating about the equilibrium position, that is x is equal to 0, and such oscillations are known as simple harmonic oscillations. That is nature of the stretched spring when released is a simple harmonic motion about the equilibrium position. So now how energy is stored in the spring? We have to find expression for energy stored. So this is the nature of the oscillations. Now when this mass M is at distance x from the mean position, restoring force F is equal to minus kx. Numerically kx is acting upon the mass. Now when it is further pulled through small displacement dx, it means work has to be done against this restoring force, and that work done, small amount of work done in displacing the mass M further through small displacement dx is given by dw is equal to f dx, or dw equal to kx dx, or w is equal to 0 to x kx dx. That is total work done in order to stretch the spring through displacement x from the mean position towards right. So k can be taken as constant, integral 0 to x dx, so it will be x square by 2 So W is equal to kx square by 2. It means amount of work done in stretching the spring or mass m through through certain distance x from the mean position is given by W is equal to half kx square. This work done is stored in the mass of the spring as its potential energy. That's why when we release the mass, this potential energy is being converted into kinetic energy. At the mean position, kinetic energy becomes maximum. Then again, kinetic energy decreases. At the extreme position, potential energy is maximum. So, kinetic energy is being converted to potential energy is being converted to kinetic energy, and kinetic energy is being converted to potential energy. So, one form of energy is being converted to other form. So, this work done is stored in the spring as its potential energy. So, therefore, potential energy stored in the spring is equal to half kx square, which is the required expression for potential energy, where k is a force constant or spring constant, which depends upon the nature of the material of the spring, and its value is force per unit extension produced. So, its unit will be Newton per meter. Unit of force constant or spring constant is Newton per meter. So if we plot a graph for energy versus displacement from the mean position, suppose the mean position plus x is the right extreme, minus x is the left extreme. Now at the right extreme, potential energy is maximum and it's given by half kx square. So potential energy directly equal to x square. So graph will be like this. For kinetic energy, graph will be like this. And for total energy, graph will be a straight line. So it means at extreme position, energy is totally potential. At mean position, when mass passes the mean position, energy is totally kinetic. And in between mean position and extreme position, on either side, total energy, that is sum of potential energy and kinetic energy, remains constant. This means potential energy stored in a spring is also explain the conservation of total energy. The total energy of a spring is also constant. It obeys the law of conservation of energy. Just like when a freely falling body falls, so its kinetic energy, potential energy, total energy graph is given by like this. You can compare potential energy stored in a spring or potential energy of the freely falling body, where potential energy equal to mgh, it increases the increase of height. At top, tension energy is maximum, but kinetic energy is 0. At height h, kinetic energy is minimum, but kinetic energy is maximum at the bottom. Total energy is again constant here. So both energy of freely falling body and potential energy stored in a spring obeys the law of conservation of energy. So this is all about potential energy stored in a spring. And it is very clear, if mass is lying on frictionless surface, so it will start oscillating about the mean position after pulling and then releasing. So, and this nature of oscillation will be simple harmonic in nature. And we can also calculate time period of simple pendulum. At this stage, no need. In simple harmonic motion chapter, I will discuss the time period of oscillation of this mass m also. So this is all about tension energy stored in a spring. In the next video, I will discuss conservative forces. Till then, stay tuned. Be happy. All the best. Good luck.